Morning Year 9. This video is about tree diagrams. And tree diagrams are used in probability for displaying the outcomes of multi-stage events. So for example, if we have two or more events that are happening, then we can draw a tree diagram to represent all the outcomes. If you have a look at this first diagram at the top of the page here, so this diagram here represents what happens, or all the different possible outcomes when I toss two coins. So you can see how it, just by the way it looks like a little bit of a tree, and hence the name tree diagram. So if imagine I'm tossing two coins. So on the first coin, I can either get a head, that's demonstrated by that branch, or I could get a tail. So that's demonstrated by that branch. So this is like either I can get a head or a tail. So that is demonstrated or displayed by that branch there. On the second coin, I get the same outcomes, but it branches out because it takes into account what happened on the first toss of the coin. So if I get a head on the first throw, the possibilities on the second throw are the same. I can either get a head or a tail. If, however, I threw a tail the first time round, the probabilities, or the outcomes I should say, are the same, a head or a tail. So we get this distinctive shape. This is called a tree diagram. And then what I can do is I can work my way along the branches and I can list the different outcomes. So here is a column listing all the different outcomes. This is the sample space. So this shows that I can get two heads. So I get two heads by going along, and I can throw. You can track it along and see that you can get two heads, or you can get two tails. That would be another. Sorry, you can get a head and then a tail. That would be another outcome. If I threw a tail the first time round, then my outcomes are going to be a tail and then a head, or a tail and then a tail. So you can see that I've got four different outcomes here. I've got two heads, I've got two tails. The two outcomes in the middle, they look the same, but they're in a different order. Head and then tail, tail and then head. So order is important. Here's a more complicated tree diagram down below. So let's have a look at this particular one here. This tree diagram represents selecting two letters from A, B, C without replacement. So that term there, without replacement, you'll see that quite often. That's really important. It changes things slightly. So what that means is that I don't have if I choose, for example, if I choose A to start with, then you'll see that on the second choice there is no A because it's already been chosen. So that's what without replacement means. It means when we choose the first one, we're not putting it back before we choose the second. So you can see similarly to here. So this is B. So if my first choice was B, you'll notice that there is no option for B the second time round. Okay? And then in this column, this final column, we've got a list of all the possible outcomes. So we can either get AB, AC, BA, BC, CA and CB. So you can see from that diagram that we got 6 different outcomes, and all are equally likely. In other words, none of these outcomes are more likely to happen than any of the others. They're all equally likely. Okay. Here's an example. We're going to construct our own tree diagram in this example. So in this experiment we have, we're asked to toss two coins. Part A says complete a tree diagram to show all possible outcomes. So in part A we've got to draw our own tree diagram to show all possible outcomes. So the first section of the tree diagram is going to be tossing the first coin. So when we toss the first coin, we draw two branches like that, and at the end of each branch I want to write down what the two possible options are. So the first possible option here is a head, and the second possible option is a tail. So that's on the first toss of the coin. Then we come across and we need to draw, we need to extend our tree diagram so that it takes in the second toss of a coin. So the second toss of a coin, so from the head, from the first one, I draw the same thing. I've still got two options for the second coin. I can have two heads in a row, that doesn't matter. And then similarly for the bottom option there, tossing a tail, I can get the same again, head or a tail. So when you draw a tree diagram, it's always good to draw or list all the possible outcomes after you've drawn the tree diagram. So if we go along, the first outcome will be two heads, the second will be a head and then a tail and then a head, a tail and then a tail. So that then takes us to our next question, part B, which is asking us, what is the total number of outcomes? So the total number of outcomes here, as you can see, is 4. 4 outcomes. In part C, it says, find the probability of tossing two tails. So the notation we would use for that would be P, brackets, tail, tail. Find the probability of tossing two tails. So what I do is, I have a look at all the different outcomes and I focus on the one which has two tails. Now, of all the 4 possible outcomes, there's only one. There's only one time that two tails appears. So there's one chance in 4. In part 2, it's asking for the probability of finding one tail. So the probability of finding one tail. Again, we can usually put the bottom number down first. It's pretty simple. There's 4 total outcomes. But what we want to do is we want to look at those outcomes that only have one tail. So if we go down our list of 4, you can see that this has one tail and this has one tail. I wouldn't count this because it has 2. So I end up with 2 over 4. And 2 over 4, if we divide top and bottom by 2, the probability is a half. So 50%. In part 3, it's asking us to find the probability of at least one head. At least one head. So what is the probability of at least one head? Well, it's important we know what that little phrase at least means. So at least means, at least one, means I could have one or more. At least one means one or more. So let's go through the outcomes and highlight those which have at least one head or more. So at least one head, that one has at least one head. This one has at least one head. And this one has at least one head too. In fact, it has two heads. So that gives me my answer now. So the answer there will be 3 outcomes out of 4. The last example is asking us to select 2 people from a group of 3 without replacement. So what that means is, effectively, I can't choose the same person twice. It wants, in part A, it wants me to list all the possible combinations for the selection using a tree diagram. So I need to draw a tree diagram. So I've got to choose 2 people. So my first, the first branch, if you like, on my tree diagram represents the first choice. Who am I going to choose first? Well, if I make the first choice, I have 3 people to choose from. Annabelle, Brodie and Chris. Now I'm going to use their first letters to make this quicker. So Annabelle, Brodie and Chris. So my first choice, I can choose 3. Now the next branch on my tree diagram is going to represent the second choice, the second person I choose. So here's where it gets a little bit different from the first example. So if I have already chosen A, then the only options left for my second choice are B and C. Working my way down, if I've already chosen B, then I have A and C left over. And similarly, if I've already chosen C, then I have A and B to choose from. So that's the tree diagram. Now let's list the outcomes. So the outcomes will be, if I work my way along the branches from left to right, the outcomes will be AB, AC, BA, BC, CA, and CB. That's what we call the sample space. That's a list of all the possible outcomes, all the possible combinations. Okay, part B asks me to find the probability that the selection will contain Annabelle and Brodie. So I need to look at my 6 outcomes here, and I need to find which ones contain an A and a B. So if we look, there's one here, and there's one here. Now, all it says is that it will contain Annabelle and Brodie. It doesn't say in that particular order. So, in other words, I'm going to count both of these. So that means that there are 2 outcomes out of a total of 6. Part 2 asks me to find the probability that my selection will contain Chris. So I'm going to go down my list of outcomes and highlight the ones which contain Chris. So there's one that contains Chris, that contains Chris, that contains Chris, and this contains Chris. So that is 4. 4 in total. So that will be 4 over 6. And my last question, find the probability that the selection will contain Chris or Brodie. Let's use a different colour for that. So I'm going to highlight the ones that contain either C or B. So that contains a B, that contains a C, B, C, C, and B. So there's only none. There's none. So there's 6. There's 6 out of 6.